I did not know.
It's like do government spending degrees. Oh, we're gonna chapter 5 now.
I knew on Monday.
Oh god, the government spends $1 billion on
We didn't like this.
No. Every single thing $1 billion in tax for Are you? No. Wait, you leave your shoes at home? Simple. What?
Alright, so today, starting chapter 5, as a high school student, this was like my favorite thing that we did in math as a high school student. I felt like this taught me more about like algebra than anything else, which is a weird thing to say in a trigonometry class, but like that's the truths. So this is going to be a little bit of a change of pace, because primarily what we're going to be doing in this chapter 5 is going to be proof. Now, don't panic. It's not like the geometry proof that you guys remember doing or not doing in in geometry class a couple of years ago. This is a 2-column proof. This is going to be algebraic. So you're just going to be like stringing equal signs together. So what I want to start with kind of primarily today is talking about like the tools we have available to us. So the first type of tool that we have available to us is going to be algebra. So things that we might say for algebra, we might say things that you might be able to do. You might be able to factor, or FOIL, or combine like terms. You might be able to reduce a fraction. You might be able to make a least common denominator and add or subtract fractions. I don't see another one right away, but that's kind of your algebra tools that we might have. The second set of tools that we have are our trig identities, which are given to you guys on that sheet that I just handed you. So that's, you should go wash your hands, right? So we'll talk about how to use that sheet here in a little bit. Right now, though, I want to focus on reviewing some of these skills. Everybody's okay?
Yeah.
I'm going to change page here in just a second. I'm just going to give a pause here because I still see people still writing before I change pages. And primarily today, we're going to work on kind of reviewing those two skills in particular. And like at the very end, we'll start layering then on the identity piece on top of that. Okay? All right, here we go. So let's go back to like Algebra 1, 2, and just kind of review some of these FOIL and factoring skills. Remember that these two techniques, FOIL and factor, are essentially reverse of each other, right? Right? If you factor something to recover what you factored back, you FOIL it out. Or if you FOILed something to recover back, what you do is factor it. back to its original state, right? All right, so who wants to help me here? We have y plus 2 times y plus 7. And we want to FOIL that out. So again, FOIL stands for first, outer, inner, last. When I multiply the firsts together, what do we get? Y squared. And then outer is
7y.
7y. Inner is,
2y.
and then last is,
14.
okay? And when we combine our like terms, we end up with, yeah. We just add the 2y and the 7y and get 9y, right? Everything else stays. Feel good? All right. The next one is 3b plus 4 times 2b minus 1. Is that really any different? What's the small complication here?
So 3.
Yeah, you have variables mixed with numbers on the same thing, right? Before you had either variable or number. Here we have both. What do you have to remember when you multiply those things together? Numbers to numbers, variable to variable, right? So when I do the first here, what do we get? 6b squared, and the outer is minus 3b, yep. And the inner? Positive 8b, and the last? Negative 4. Feel good? Okay. We have some shortcuts that can make multiplication a little bit faster if you see the shortcuts. Now these shortcuts for multiplication, it's doing the same thing as FOILing, right? All we're doing here with these shortcuts is taking advantage of being able to show less work. To take a FOIL problem and turn it into something conceivably we can do in our head. Yeah? Alright. So if I have x minus 3 squared, that looks like this situation, right? So the x is like my a, and the 3 is like my b. So I can go straight to the FOILed out answer using that formula. And realistically, the 2 times x times 3, something I can do in my head, right? So I don't even really need to write anything intermediate step down there. These are notes, so I wrote down the intermediate steps so you can see how I use the formula to get the 6x. But ideally, the hope is that you can write that down without having to do any intermediate. Everybody's okay with how I'm using that pattern to bypass the FOIL situation? Okay. The next one, what do we notice here? Yeah, this is the difference of 2 squares. So again, that should just be, if I notice that's my a and b, so I should just have y squared minus 25. Lovely, right? Ripped right through that. Nothing to do, right? No big deal? That's the idea, right? Okay. If I do the next one, that's another perfect square with subtraction, right? A minus b squared. Everybody agree? This time the 2a is my a, and the 1 is my b. What's 2a squared? 4a squared. How'd you get the 4a? 2a squared is 2a times 2a, right? 2 times 2 is 4, a times a is a squared. Cool? And then 2 times 2a is 4a, and then 1 squared is 1. Everybody feel good on what we've done so far? No big deal, I hopes. Okay. This last example, hopefully you can see pretty easily, is the perfect square with addition. Who feels brave and can spit out the final answer without doing any intermediate steps here? Who's like, I can do this stuff in my head, Mr. Cool, like I got it. The shortcut is so nice.
3z squared.
Ooh, already up.
9z squared.
There we go.
Oh, I forgot.
Plus 16.
Forgot to do the multiplication.
16.
18.
18.
8.
12.
12.
What?
Yeah. 24.
24 is the right number.
Oh.
3z, or 2 times 3z times 4. Again, if you struggle to do it in your head, don't have to. What we're doing is presenting the shortcut here to bypass the FOIL. The more comfortable you get, the easier doing those sorts of things will be to do in your head. Okay. Let's now go the opposite direction. So here we're going to be factoring. Who can tell me how to factor x squared plus 4x plus 4? Okay, so pause here. Guys, this is expected to be a mastery level skill for you at this point. You do this in Algebra 1. You do factoring in Algebra 2. I know for a fact Mr. Boyle spent over a month working on this single skill in Algebra 2 with each and every one of you. And did not let you pass and stop doing this until you could do it at a satisfactory level. The expectation is that this is a skill you have mastery over still. That you can do this quickly and accurately. Okay, we will refresh now, but this is a problem. Like if you look at this and I don't know, I have no clue what to do, what the heck are you talking about? You need to do something about it yesterday, okay? I want to be clear. You're sitting there, I ask you a question, everybody sits here for 30 seconds, nobody says anything and just kind of looks around. That's a problem, okay? This is the expectation. I don't want to beat around the bush about it. I want to be really clear about where we're at right now and what is expected from this class. It's one thing if we're talking about logarithms, which I know you do for the first time in Algebra 2, and it's hurried and it's at the end of the year and you aren't able to do as thorough a job as we'd like. That is acceptable. This skill that you do at the beginning of the year and then never goes away throughout the rest of the year, this is one that I expect that we're quite confident at and quite good at. Okay. Who can tell me how to factor x squared plus 4x plus 4? Mark.
Find out what can go into the x squared and the 4 and figure out what adds to the 4 in the middle.
Okay, and what do we get?
You get 2. It's just 2.
Okay, so the factored form is?
X plus 2 is squared.
Okay, thank you. So what Mark says is that to do this, you found the two numbers that multiplied to give you 4, and the two numbers that add to give you 4. Which problem are you checking first, the multiplication problem or the addition problem? Which one has finitely many answers for integers? It's not the addition problem, the multiplication problem. There are 4 integer answers that multiply to give us positive 4. 1 and 4, 2 and 2, -1, -4, -2, -2. Those are the only 4. How many sets of integers are going to add to give us positive 4? Infinitely many. 0 and 4, 1 and 3, 2 and 2, -1 and 5, -2 and 6, -3 and 7, and it goes on forever. Which list would you rather deal with? The multiplication list. What are you doing with the multiplication list? You're checking those against the addition list afterwards. You start with the finite list and check it against the infinite list. You don't start on the infinite list and try to check it with the finite list. That's madness. So, in elementary school, in middle school, you spend a bunch of time memorizing multiplication table. The reason you do that is because you need to have your multiplication tables to do this quickly and efficiently. If you don't know those, I'm going to hand you the touch and tell. Okay? 4 times 4, 16. Practice it up. If you need it, here it is. Okay? But that is the expectation. We're doing this, should be able to do this without calculators. You should have these times tables down to where it's instant recall. It's a mastery skill from 3rd and 4th grade is probably where we start multiplying, right? Does that sound right? You've done it every year since then? You should be masters at this by now. Okay? If you're soft on these skills, you need to practice. Because that's what's going to get in the way of the stuff that we're layering on top of it. If the foundational skill is bad, the next set of skills are going to be harder than they need to be because you're like, 2 numbers to multiply to 56. 8 and 4? No. And you just, it's like there's not that many answers to that. 156, 228. 4 and 14. 7 and 8, and then the negatives. Should be quick. Should be able to do in our head. If it's not, it's going to be rough sledding. Okay? Let's look at number 8. What's the complication of number 8? What makes 8 fundamentally harder than 7? There's a coefficient on the squared term. But there's an out here. If you look at all the coefficients, what do you notice? They all have a factor of 2 in them. What should we do first then? We can't divide by 2 because it's not an equation. If this was equal to 0, then yes, dividing by 2 is valid. There's no equal sign here. We can't divide by 2. We factor out at 2. So what is that called? What type of factoring are we doing here? Greatest common factor. GCF. Yes. Now the remaining problem, z squared plus 3z minus 54, that should be doable, right?
Oh, yeah.
What do we need to do to factor z squared plus 3z minus 54?
So we would multiply the base 54.
Okay? What are the two numbers?
Negative 6 and positive 9.
-6 and +9 is correct. Does it matter the order that I write z minus 6 and z plus 9?
No.
It does not. Everybody feel good?
Yep.
All right, let's look at number 9. Can we do the same trick?
No.
No. How does the problem change? Because now it becomes much more difficult, right?
Yeah.
This is the hardest version of these factoring problems we'd expect you to be able to do. At least at this point. How do we start this one?
2 multiplied by 2.
Find two numbers that multiply to 24. Why 24?
Isn't it negative 24?
Yes, it's negative 24. Mr. Kulik, why all of a sudden do I have this times 2 here? We didn't do that before. We did. We did. What is the number here?
There'll be a negative.
We did. You were just sloppy about it and didn't write the times 1 or didn't say the times 1. I think Mark tried to at the very start, in fairness to Mark. But there is a 1 times 1 that we did in each of those problems. We just didn't write it down and we didn't say it, but the process has not changed there. We're just able to be a little bit lazy about it, and it doesn't hurt us. On these problems where the coefficient is not 1, you gotta remember that. Everybody's okay? Yeah. All right, continuing on. So multiplies to give us negative 24, adds to still give us 5.
Negative 3 and 8.
Negative 3 and 8 is correct. Well done. That was excellently fast. Although I did stall a little bit there to give you guys time to think about it. All right, here's the hitch. Doesn't take us straight to the factored form. Right? What does the negative 3 and negative 8 tell us? It tells us how to break apart the 5b so that I can do a factor by grouping. So we have 2b squared plus 5b minus 12 is equal to 2b squared minus 3b plus 8b minus 12. Everybody okay with what the two numbers allow us to do? Tells us how to break apart that middle term. Everybody, the highlighting, I'm going to try to highlight and help to point these things out.
Good.
It's good? All right. Now, what do we do after this step? We've broken it apart. What do we do?
Put it back.
Put it back. If we combine back like terms, we're back to where we started. We don't want to do that. Yeah, we make two groups, right? When you make two groups, though, the thing you must remember is you have to have a plus sign in between your two groups. What if I had a subtraction symbol there? How do I cope with the subtraction symbol there?
It'd be negative, so you'd have to like.
You rewrite your subtraction as plus a negative, right? So if instead we had written this middle as like plus 8b minus 3b, we can't do this because there's not an addition sign there. We just write it as plus the negative and everything is fine. Is everybody cool? Okay. So I'm not going to bother putting it back because it doesn't matter which term you put first. This one does a nice job of illustrating like the plus and negative trick that we might need. All right. Then what? We've made our two groups. Now what do? We do not set them equal to each other.
You give them to the lowest.
Now, you get them, you factor out, B from the first one and 4 from the second.
Close,
Negative 4 from the second.
close. Remember I moved things, right? Because I talked about something, so I moved the order. So you're not quite right because I changed the problem on you. Mark, so what we're doing is taking out a greatest common factor from each group. The first group, 2b squared and 8b, the greatest common factor is 2b or not. No, nobody thought, okay. Just making, English jokes here for you guys. No Hamlet fans. How about negative 3b minus 12? Negative 3. Is everybody okay here? Alex? Okay, so what do we do next then?
Then you take the 3 plus 4 and then put it together, so that's 3 plus 4, and then you take the 2b and minus it, and that also.
And that's our final answer, right?
Wow.
Oh, thank you.
So I remember how to do it. It's just it's coming back to me,
All right.
I'll just quote his, or is it?
Sure. Is everybody okay? Let's look at number 12 here. Three cosine squared x plus cosine x plus 10. I'm sorry, plus 13 cosine x plus 10. What? You're telling me we're going to start mixing trig things into this factoring business that we've been doing? Yes. Yes. Now, when you look at this, whether that's a cosine there, should make no difference at all. So let's imagine that we just replace those cosine x's with some just regular different variable, let's say a. If I do that, 3 cosine squared x just becomes 3a squared, right? 13 cosine x becomes 13a. And 10 is 10. This is now identical to the type of problem we just were doing. Any problem with 3a squared plus 13a plus 10 looks completely familiar, right? We do it the exact same way. And as the final step, what will we do? We just put the final step, not the next step. The final step, we just replace our a's with cosine x's. We're done. Is everybody okay? Again, the hope in mathematics, we take something new and turn it into something old, do it the old way, and then turn it back, and we're done, right? Every time we can take something new and turn it into something we already know how to do, we're doing a good job. Because we don't want to invent new methods, we just want to turn the new thing into the old thing. Good? Okay. So, how do I factor 3a squared plus 13a plus 10? Two things that multiply to give us 3 times 10, so that's 30. And then add to give us 13. 3 and 10. So we're going to have then, I'll just go over here, 3a squared plus 10a plus 3a plus 10. Make two groups. Again, gotta be careful that we're putting the plus sign in the middle of the two groups. There must be an addition symbol there. From the first group, what can we do? Take out a greatest common factor of A. Second group, what's our greatest common factor? 1. Notice that 3A and 10 are relatively prime, meaning they share no common factor. Have to take something out though. That common factor has to be 1 in this case. Everybody feel good? Next step would be?
Combine A and 1 in one group and do.
Okay, so if I factor out the 3A plus 10, right, that those just become there. The leftovers then is my other group. Are we done?
No,
Okay. All right, what's up, Mark?
does it matter which like factor you place on which side, or do they just run the same answer?
You get the same,
Okay.
yeah, the grouping will look a little different. And like the order that you write the two factors would be different, but whether you wrote it as 3A squared plus 3A plus 10A plus 10, or the way we wrote it, you'll get the same result. Now, I'd asked, are we done? And some of you had said no. What do we still need to do?
Place where you get cosine.
Got to put the cosine x back in. Very good. And that would be our final, right? So does it really make any kind of difference to us if I make a polynomial thing with a trig in there and we ask to factor it? Doesn't really do it. It's still the same problem, right?
Yeah.
You have a little tiny step at the beginning, a little tiny extra step at the end, but like they're really pretty trivial. And in fact, once you're good at it, you don't even need to bother with the substitution. You just see it as the substitution and you can just go. But if you're not there at the start, that's okay, right? If you want to write the substitution, it makes it easier for you. Do that. Once you've done that for a while, you'll probably get to the point when you feel comfortable about like, I don't even need to do the substitution anymore. And that's great. That's where you should get to. Now, remember those special factoring or special multiplication patterns we talked about before? Equal signs can be read forward or backwards. So those multiplication patterns can also be used as factoring patterns. So that's what we want to practice here as a shortcut. Okay? So if I look at this, x squared plus 10x plus 25, before I start trying to factor this the normal way, I'm going to look to see if any of those special factoring patterns apply. It's obviously not a difference of 2 squares because there's 3 terms here, right? But if I look at the first term and the last term, I notice that those are perfect squares. So maybe it's one of those addition perfect square, subtraction perfect square. Maybe I'll just write it. Okay, come on now. I just erased something. Why do you think I'm trying to do this? So my A is like my X, and my B is like the 5. And what I'm checking is 2x, or 2 times x times 5 equal to 10x? Yes. So what this tells me is I just have x plus 5 squared. Alex.
For the ones that have 3 terms, where they have like 3 terms in it, is it always the outside? Is it always the first and the last one that we use for the A and B?
So the only time you need to bother with trying to do this check. Now, I want to point out to you, you could factor this just like we have been, right? And here, where the leading coefficient is 1, you might as well, right? This is saving no more time doing it this way than not, right? Where this would become helpful is if you had like 16x squared plus something plus 36, where it's like, oh, I have to do 16 times 36 and look at how many factors that are, and there's like a bajillion, because those are numbers that have tons of factors in there, and it stinks, right? If I can avoid having to like find all the factors of 16 times 36, instead of just by doing this little like, 2 times 4 times 6, and does that check with the middle give me that every single time? That's so much simpler. Does that make sense what I'm saying?
Yeah, so like for 14, because it's.
Hold on, we'll get to 14. We'll get to 14. But does everybody see what I'm doing here in terms of the check? Now, ideally, this check I'm doing in my head, right? I see the A is X and the B is 5. And I just check, does 2 times X times 5 give me 10? Or 10X in the middle? It does, so I go straight to my factor. I don't have to write anything down. I'm writing it down so you can see what I'm doing when you go back and look at this later. But ideally, this is one that you could do in your head. If you can't, it's okay. But that's the value here, is that you can shortcut having to do a lot of work. And in the case of something this simple, you're not really shortcutting much, right? Because it's relatively easy. All right. Everybody's okay? 14. We notice there's only 2 terms, right? And the other piece that I'm going to look for is that the middle term, or the middle, is a subtraction symbol. Everybody good there? So that could be a difference of 2 squares, right? So to check that, I'm going to check, is the first term a perfect square? Of course. And is the last term a perfect square? Yes. So I can go immediately to my factored form. I'm done. Right? That's my difference of 2 squares factoring pattern. A squared minus b squared equals a plus b times a minus b. Hopefully that's one you still have memorized from Algebra 2, because boy howdy, that's helpful, right? Happens a lot. Super helpful, easy to remember. The thing you got to remember is that you have to have the subtraction there, right? On occasion, I'll see kids want to make a squared plus b squared factorable, and that is not factorable over the reals. You could factor it over the complex numbers, but that's typically not something you do in your algebra class, or something we worry about in this class either. All right, let's look at the last, or number 15 here. We see these cosines again. Does that make any difference to us though? No. So, I see 3 terms. Let's check to see if they're, the first and last are perfect squares. Cosine squared x, is that a perfect square?
Yeah.
Yes, right? It's just cosine x squared. So the a would be cosine x. Everybody agree? Is 9 a perfect square? Yes. 9 is 3 squared, so the b would be 3. So my check now to see if this is the factoring pattern I'm looking for is, does 2 times cosine x times 3 give me the middle term? 6 cosine x. And it does, right? So I can go straight to my factored answer, a plus b quantity squared.
And you said 2 cosine x?
So the middle term, if this is a squared and this is b squared, this middle term has to be 2 times a times b. Is that okay? Because in both the subtraction patterns, whether it's a plus b squared or a minus b squared, the middle term is 2 times a times b. So that's all I'm checking if there's 3 terms. And that's just as a shortcut, right? Just as a shortcut. All right, folks, how do we feel about foiling and factoring? We feel adequately refreshed? Do you remember doing these? A little bit sharper than when we started? Okay. So now we're going to actually start the meat of what we're going to be doing in this unit. Now, this first starter problems that we have are going to be things that are primarily like factoring or foiling is going to be like the critical step inside of them. Eventually, we're going to look at some other algebra things that we have to circle back to and practice those, and then show a problem where that comes in, and then eventually it just kind of all gets mixed together and the training wheels come off and like figure it out. But for the beginning, we're going to look at these slowly and carefully with like limited things that can happen. So the directions here say simplify the following expression. When we say simplify, what we're looking for is to end up with a less complicated expression than what we started. Ideally, what's the simplest thing we could have left? One thing, right? Whether that's a number or just one trig function, but like that's the simplest things go, right? What's simpler than one thing, or what's the next least or the next less simple thing? 2 things, right? Whether it's like as a fraction, like something divided by something, or something times something, or something plus something. That's slightly less simple, right? And so on and so forth. Is everybody good? So if I look at this, I see 2 things, right? I see sine cubed plus sine x times cosine x. 2 things. Everybody agree? Okay. So my goal here is to make this simpler. Typically, on these sorts of problems, the first thing I'm going to look for is an algebra thing I can do. Okay? So your algebra things are factor, foiling, combine like terms, common denominators, reducing fractions, things like that. If I have 2 things, right, I have something plus something, what algebra thing is the most likely or algebra things maybe are the most likely things I can do. So factoring, and then maybe combining like terms, but this is obviously not like terms here, right? And it's not fractions to where I can add and make a common denominator to add and subtract it. Factoring is probably the place where I want to be checking. So if I look at sine cubed x plus sine x times cosine squared x, how can I factor that? Perfect. Yes, so if I look at them, we should see a greatest common factor between them. What is the common factor between sine cubed x and sine x times cosine squared x? Sine x. Does everybody see that? When I factor the sine x off of the sine cubed, what does sine cubed become?
Sine squared.
Sine squared. When I factor the sine x off of sine x times cosine squared x, what does sine x times cosine squared x become? Cosine squared x. That is correct. Now I'm going to pause here because Alex answered all of my questions pretty quickly. I want to pose to the rest of you. Do you understand what just happened?
Kind of.
Kind of. Do you have a follow-up that you want to ask to clarify it a little bit more for you? Because kind of is good, but it's not great.
Oh wait, oh yeah, it makes sense.
You see it? Okay. Frankie?
Is that a sine
Square root of 3 or to the third power.
In the problem, yes.
Okay. No.
Yes. That's a sine cubed. Okay. So we've done an algebra step, right? And then really it's a pretty good one, because what have we done? We've taken two things and turned them into one thing, right? Now that one thing is still pretty complicated looking, so I don't feel particularly good about being done, but it's a step in the right direction. Everybody observe what I'm talking about? So typically now, after I've done an algebra step, I'm going to take my identity sheet. And I'm going to look for an identity that I can use with the intention of making this simpler. So, sine x is just one thing. Unlikely I can do anything there. It's the inside that I'm going to be most interested in. Because I see squareds and addition symbols, the place where I'm going to be looking is at my Pythagorean identities in the middle. I know you guys see it. I'm really excited for you. I really am. I'll call on one of you, I promise. Okay? Is everybody okay? Because if you look at the Pythagorean identities, they all have things that are squared, that are being added or subtracted. Everybody see that? And they're the only identities that have any addition subtraction in them. You guys see that?
Yeah.
And I can only use them if they have things that are squared on them, which is what I'm looking at there. So Isaac, what do you see?
It says that it equals 1.
He's looking at P1, that sine squared plus cosine squared is equal to 1. So while I'm writing my work, I'm going to write like P1 over the equal sign, so that when I go back and look at this later, because I haven't really memorized any of these identities, I don't know them by heart yet, because I have just seen them for the very first time today, I can look and go, what the heck happened? Where did the sine squared plus cosine squared go? Why did it become 1? I can go, oh, it says I used an identity there, P1. So it told me what to do. I would not ask you to memorize these in this class.
So, why did the sine x carry over to the 1?
So, this piece
Is the 1.
is the 1. So this piece
Okay.
just hangs around for the rest.
Yeah, that makes sense.
Is everybody okay? Highlighting often helps. Again, if you're confused at like what's going on, I can highlight things so you can see like what's staying and what's changing. All right, what should we do next? It's kind of an obvious question.
The next problem?
Well, we're not quite done. There's something we can still do here. Times them together, right?
Oh.
We can do that. What's sine x times 1? Sine x. How many things do I have left now? 1. Can it get any simpler than like just a sine x? Not really, right? I don't have anything else to do to it. It's done. Like, that's it. We're done. Finished. Finito. Single trig function. That's pretty good. The only way it could be better is if it was just a number, but like, I'm not surprised I didn't get just a number out of this. Considering that there was like no coefficients anywhere in here, right? So far so good? Alright. I think we're coming like right to the end of this, right?
Yeah,
We have like 4 minutes left.
Yeah.
4 or 3 minutes.
Okay. Let's stop here. For next class, I don't want you to do anything. Okay? I want you to do anything. This is a rather difficult skill at the beginning. You guys have no intuition right now about like how to proceed on this. We're going to take some time here at the start in class to try to build some intuition out, where we're going to continue doing what we did here today and like asking you guys, what do you think we should do? And I'll do some stuff and like tell you why it's a good idea or a bad idea and help build out the intuition. But until you have that built, these are extraordinarily difficult problems to do on your own fresh. I'm not asking you to do that right now. We're going to build this up in class before I send you off to try it on your own, which is why I'm asking you to do nothing right now.
So, is the chapter 4 review due on Sunday?
Yes, that is the Sunday problem, that is the chapter 4 review, if you haven't done that and loaded it. Many of you probably have, but that is Sunday's homework. Correct. Chapter 4 review.
I might be able to help with the whole moving, with the whole current.
Yeah, sure, go ahead.
I thought, okay, let me try.
Press
I
that
thought-
picture's background.
Oh my God.
So I thought it was purpose, that's why I said
Thank you, that makes my day, really does, like, you don't know how
And then I just.
angry I get all the time at the stupid thing taking over.
Yeah, so that, if you do that for like every paper you do
Yeah.
on there, it should
Stay put.
stay put.
Ian,